All right, today I'm going to show you how to do the practice performance task, and I'm going to go through number 1. So firstly, let's go ahead and read through it. Jessica's learning about health in school. There was a moment in class when she realized how important eating breakfast was to her health. Jessica reflected that she doesn't eat breakfast often, and when she does, she eats her brother's cereal, which she predicted was not the healthiest choice. Jessica also learned about the importance of fiber to the body, especially at the beginning of the day. So Jessica decided to collect data from all the cereal sold in her local grocery store and complete a statistical analysis of the results. She wanted to know, is there a relationship between calories and grams of fiber in a breakfast cereal? So to be really clear what fiber is a plant material that is mostly indigestible. However, fiber stimulates the intestine to help digest other food. Okay, so to start, we're going to go ahead and the data for the 76 cereal brands are listed on the second tab, and actually that should say first tab of the Apply It spreadsheet from question number 1. Okay, so create a scatter plot of the data. So I found this on Classroom. You go to Classroom, you open this up, and I'm going to go ahead and create a scatter plot of the data. So to create a scatter plot, I select only the data, not the names. Select all the data, and then insert chart. And then I'm going to choose a scatter plot. I'm going to go to customization. And in customization, quickly take a look at the title, calories per serving versus fiber. I'm going to put the legend at the top. The horizontal axis goes 0, 4, 8, 12, which is fine by me. Just take a look and see if I were to do 6, 3, 6, 9, 12. I like that. 7, that's no good because it has decimals. This is good. 2, 4, 6, 8, 10, 12. And maybe I put one minor line. So it's 1, 2, 3, 4, 5, 6. Let's go to the vertical axis. That would be my y-axis, calories per serving. It goes 50, 100, 150, 200, which isn't too bad. Let's just see what 6 does. Okay, that goes by 40s. 7 goes by 30s. I like 30s better. And maybe I'll put 2 grid lines, so it'd be like 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so I'm going to go ahead and do that. Hit insert. Here it is. I'm going to drag it over. Oops. Hello. And I'm going to put it in this box. Maybe I'll make it fit for the fun of it. Awesome. All right. Question B. What is the linear regression model? Model includes real-world variables, not X and Y. Record on the spreadsheet where it says B. Okay, so I need to go back and edit this. Advanced edit. And I'm going to scroll all the way to the bottom where it says trend line. And I'm going to choose linear. Then I'm going to make sure that the label says use equation. So there's my equation. I'll update it. I'm going to write that in B. So y equals negative 2.399 times x plus 112.045. Except it said use real world variables and not x and y. So x is actually the x-axis, which is fiber, and y is the y-axis. So that would be calories. Okay. C, provide an interpretation of the slope of the regression model in context of the problem. Record it where it says C. So the slope, I'm going to make some notes over here. The slope is rise divided by run. Oops, let's do this. Make this all like 12. Okay. Rise divided by run, right? And the rise, right? So this is negative 2 point, I'm going to round to 4, negative 2.4, right? Divided by 1. And so what this means, and remember, rise is an up and down movement. So that's really traveling along the y-axis, which really means an increase or decrease in calories. The run is really a left and right movement, which is the x-axis, which the x-axis represents grams of fiber. Okay, so this really means like negative means decrease, 2.4 calories, and 1 is technically positive, so increase 1 gram fiber. Okay, so what does this really mean? For every 1 additional gram of fiber, the calories decrease by 2.4 calories. Okay, so if we increase by 2 grams, then it'll decrease by 4.8 calories, so on and so forth. Question C, Cinnamon Toast Crunch has 0 grams of fiber. What is the predicted calories per serving based on the model? Write a complete sentence. Okay, so Cinnamon Toast Crunch has 0 grams of fiber. So since it has 0 grams of fiber, we would do y equals negative 2.399 times 0 plus 112.045. Okay, so negative 2.399 times 0 is 0. And so this really is 0 plus 112.045, which means it's 112.045. So to be clear, what is the predicted? Okay, so considering Cinnamon Toast Crunch has 0 grams of fiber, the linear model predicts, I'm going to abbreviate Cinnamon Toast Crunch to have 112, I'm going to say about 112 calories per serving. Okay, question E. Is the data point 0, 120 above or below the regression model? Let's check that first. 0, 120 is right here. And so that point is above the regression model. So the data point 0, 120 is above the regression model. Oops, forgot to close that. Okay, next part. What does it mean in context of the data for the data point to be above the regression model? So remember, if it's above the regression model, then that means, because remember, these are the predictions. And this is what actually happened. So what actually happened was more than what we predicted. Specifically, the number of calories in a cereal that has 0 grams of fiber was more than what we predicted. The number of calories in a cereal with 0 grams of fiber was more than what the model predicted. All right, A, B, C, D, E, F. So calculate the residual for each data point and record it in the column titled residual. So now I'm going to go ahead and calculate the residuals. In order to calculate the residuals, I first need to calculate the predicted calories. Because remember, residual is actual minus predicted. So in this cell, this is going to equal negative 2.399 times the grams of fiber plus 112.045. Hit enter. Then I get to drag this all the way down. So those are all the predicted calories based on the grams of fiber. The residual is equal to the actual minus the predicted. Drag that all the way down. So here we've calculated all the residuals. All right, interpret the residual for Cinnamon Toast Crunch. Write a complete sentence. So Cinnamon Toast Crunch is here. The residual is 7.955. And again, that point was above the regression model, which means, right, based on the fact that there are 0 grams of fiber, Cinnamon Toast Crunch has 7.955 more calories than what we predicted. And as we can see, it actually has 120 and we predict it would have 112. So we would say something like, considering the residual is 7.955, this tells, considering the residual, let's say for Cinnamon Toast Crunch is 7.955, this tells us Cinnamon Toast Crunch has 7.955 more calories per serving than the model predicted. All right. H, create a scatter plot of the residuals in the orange box. Okay, so we're going to create a scatter plot of the residuals. So to start, I'm going to grab all the grams of fiber, because this is X. And I'm going to say insert chart. Then I need to actually add more data. So I'm going to click here. And I'm going to add a range. And I'm going to choose all the residuals. If you didn't get how to do that, rewind the video. Chart types, I'm going to select the scatter plot. Okay, and then customization. I'm going to really quickly change this. This is just a scatter plot of the residuals. And then I'm going to quickly change the horizontal axis to, this is grams of fiber, which is great. And then I make sure the title or this axis is labeled residual. And then maybe I'll change this really quick so that it was the same as the other one, which I think went by, yeah, it went by 2s. Perfect. Looks good. Here's my scatter plot of the residuals. I'm going to put it in the orange box. And maybe I'll make it fit. Awesome. Cool. That looks a little crazy. Huh. All right. What does the residual plot indicate about the model? So when we do this question, we're looking for, does this have a pattern to it, or is it pretty scattered? And I would say that it does kind of get a little bigger and then smaller, but it gets bigger in the same direction up here too. So I would say that this is kind of scattered, but it doesn't really have a pattern to it. When we think of a pattern, we think of like a curve to it. And so I'm going to say, considering the scatter plot of the residuals has I'm going to say a little scattered and is lacking a pattern. This tells me the linear model is a good fit for the data. If it did have a pattern to it, then we would say that the linear model is not a good fit for the data. Compute the correlation coefficient and record on the spreadsheet where it says J. So this cell is going to be equal to coral. And then I'm going to select the Y data first. So the Y data, calorie per servings. I'm going to hit comma, X data. Close my parentheses. Wow, that's not an awesome number. Okay, cell K. Do you feel the linear model should be used to predict the number of calories per serving based on the number of grams of fiber? Based on this correlation coefficient, I absolutely do not think we should use the model, because remember, the point of it, the correlation coefficient tells us how good of a predictor this is. And the fact that it's negative 2 point, like let's just say negative 0.3, means that it's a very, very weak relationship. And so my answer to this question is I would not use the linear regression model to predict the number of calories per serving of cereal based on the number of grams of fiber. I came to this conclusion because the correlation coefficient indicates a weak, I guess I should say what the correlation coefficient is. Correlation coefficient R equals negative 0. I'm going to round to 3. Indicates a weak negative relationship. And that's it. You could have also talked about the residual plot and the fact that the residual plot, well, no, it does say the linear model is a good fit. That's it. Go ahead and do question number 2 on your own.